So hello everybody. I would hopefully like to finish the last 30 slides in chapter 12 today. So picking up on capital budgeting, we could have two projects with unequal lives, which means one could go on for 10 years and the other one could go on for 3. And the question is to evaluate these two projects and find out which one is worth doing here. So we follow a couple steps, and first what we got to do is calculate the net present value of each project independently by itself, right? So you act like they're independent, and you just basically calculate its net present value. And the next step is, if you go back to a lot of this is a 330 review. You convert the net present value into an annuity, and so basically what you're doing is you're finding an annuity that has the same life and the same net present value as the project. And the last simple step is to select which project has the largest annual, and now it's called an annualized net present value, ANPV. Okay, so I believe there's an example here. So we have two projects we can apply, right? So the net present value of projects X and Y that we saw earlier were right here, and obviously this one was more. They were both positive, but net present value Y was more worth doing, right? So I believe these had unequal lives, right? So what we got to do is figure out which one is worth doing. Alright, so we already got step 1 done. So we got to convert these net present values from step 1 into annuities. So basically we have a 3-year annuity for project X. And we have for project Y, you can see we have a 6-year annuity right here, right? And that has the present value of that. And basically that's all really the where the work lies. And we can use basically either a calculator to get the annuity, right, or payment, right? And you'll notice these are what the payments are. You notice they're negative because we're paying it out, right? It comes out negative. But so this is 3 years, right? And this is 6 years. Here's the present values we just calculated. And here's the Excel version of that. So we could basically have an Excel version. Alright, so if we go back a minute before I even do this, we can see what the annualized net present values are. And you can clearly see this one, and they're very comparable, right? But this one is slightly more positive than that one. So we would choose, you see what it says here, choose project X, right? But, they're so comparable that the question is, does it really matter? So project X would be the recommended project because it provides the higher annualized net present value. Alright, so real options, I won't spend too much time on that. Basically what it is, just an option if you have, and they're called strategic options. Let's say you have a factory and you oversized the factory, or you bought a house. I'll give you a simple example. You bought a house with a lot of extra rooms, right? What's good about that? Well, it gives you options to rent them out, right? So you made a strategic move, and so those options have real value. See value of real options here. And there's a nice little table here that gives you all the different types of real options. Abandon a project to get money for it. And here's like flexibility, like I just said, if you rent out a room, right? And so there's all different types of real options here. Alright, so there's a way of calculating them. I'm not going to spend too much time on this because it gets a little complicated, for an undergraduate class. All right, so capital rationing. Let me grab a sip of coffee, if you don't mind. Capital rationing is basically, you only have so much funds, right, available. And you can't go crazy. It's like we live under capital rationing, right? We can't spend everything we make on ourselves, right? So we basically we look at the internal rate of return. If you remember from basically from 330, how we calculated net present value, then we calculated the internal rate of return, and that was the return where the net present value equals 0. Remember that? So basically, you're going to plot all the different internal rates of return and look at what's called an investment opportunity schedule here, right? So remember, the internal rate of return, if you remember, is where net present value is 0. And I believe I have the slides up from the earlier chapters because we use the same book. So you can go back and review the earlier chapters. So here's the initial investment, and here's the internal rate of return, and the cost of capital is 10%. And it's got a fixed budget of $250,000. So which projects would be most worth doing, okay? So they only have $250,000 to spend. So if we look at this internal rate of return, I guess it starts becoming obvious which ones we should do first, right? So let's look and see. So, right, you can see B gave us 20%, right? And let's go back for a minute. It's B, C, E. So B is 70, and this is 100, and right? And so we got 170,000 and another 60,000. So we got about 230,000. So those were the three highest internal rates of return. And you could see BCE, and we have a little extra money left over here, right? Maybe for something else. Giving everybody a raise. So they go through that here. And you can clearly see, like I just said, you have $230,000 available. All right, and you can do the same thing with the net present value approach, right? Instead of internal rate of return. So here's the initial investment, and here's the present value of the inflows at 10%. And here's the internal rate of return we calculated. So B, C, and E will yield a present value of 336. However, if we do B, C, and A, the total would be 250,000. So basically, the present value of the cash flows would be 357,000. So doing B, C, and A, because we only have enough cash to do those, is comparable, right? We got B, C, and A here. It's preferable. They maximize the present value for the given budget, right? So you can see, if projects B, C, and A were implemented, the total budget of 250,000 would be used, and the present value of the cash flows would be 357,000. So you can clearly see here that we're making optimal use of our present value. All right. So this is net present value versus internal rate of return. Go through them both, and if you have any questions, ask me. All right. So that's about it. And this is about 9 minutes long, and I'll upload this. All right, everybody. Take care. All the best.